you can take a hardwired contact from the pH transmitter that's measuring the pH and wire it through a relay directly to the metering pump and just shut it down. And who cares what the PLC is telling it to do? And in those cases, our design engineers need to think about that and build that in.
If we're going to talk about water, we got to start with the big thing. We got to start with Oldsmar.
Yep.
Someone got in, they got to an HMI, they increased the level from 100 parts per million to 11,100 parts per million. What I'd like to run through with you, Gus, is the actual physical part of the water system. Would a water system ever want the capability of delivering 11,100 parts per million of sodium hydroxide?
No, of course not.
If I am programming my PLC, I am not going to accept a command in my PLC if I'm writing my logic correctly. I'm not going to accept the command to dump 11,100 parts per million, right? I'm going to have some boundary checking in my code. That's possible, but an attacker, in theory, if they were in the system, could reprogram the logic.
Absolutely.
So let's assume they reprogram the logic and the PLC, in fact, wants to execute a command to dump 11,100 parts per million of lye into the system. I would think the next thing would be, is the system capable of supplying that much?
Right.
Like, have you physically set it up so it could supply that much? So would you ever set up a system that had that possibility?
No. I don't know what that's like a ridiculously high amount. That's like off the charts high. That's somebody who did input validation in, which is normal. Actually, what would limit it is simply the output of the pump. And that could be dangerous, right? So one thing you touched on is the PLC. And typically, even with something like this, you won't find any hardwired physical interlock that's going to stop that metering pump. What's going to stop the metering pump from running on high pH, unfortunately, in a lot of cases, is in that PLC. The high alarm to say shut down is usually that logic is in the same PLC that's running the process, which is a weakness and a problem.
How big are these chemical bins?
So that's the thing. It varies widely from water system to water system. I've been in a lot of water utilities, and they are not the same ever. They really vary significantly according to the source water that they're treating.
Okay, well, let's stay with kind of the worst case.
Yeah.
So hacker got in, the HMI sends the command, has modified the PLC so it will actually send that command to the pump to put out as much as the pump can put out, and turned off any alarming in that same PLC. And let's say it's a big vat of chemical, so there's plenty of sodium hydroxide, and it's going in close to where the distribution system, kind of in the worst spot. What would happen next? Would there be any sort of post that point water quality check? Are there filters that would break down? Any alarms that would go off? What would happen next?
Nope, you get it. So there's precedence for this. In Spencer, Mass. in 2007, an operator was doing some sort of calibration. I think they left a metering pump running in manual and overnight, and it built up a huge slug of sodium hydroxide at a low demand period in the morning. The people of Spencer, Mass. started taking showers, and 100 people went to the hospital with chemical burns. Them just changing that set point, fine. There's so many things that are going to stop that bad thing from happening. But as you had pointed out, the level of access they had to get to that HMI, there was so many things that could have happened that would bypass all those protections. And that's why when this happened, Oldsmar happened, I was at Dragos, and I wrote a blog on it, and I put out a little sketch. Like, I feel like this is where we need to be, is where you have those legitimate health and safety impacts. That's where we need, it's not a very scalable solution across the whole industry, but like you can take a hardwired contact from the pH transmitter that's measuring the pH and wire it through a relay directly to the metering pump and just shut it down. And who cares what the PLC is telling it to do? And in those cases, our design engineers need to think about that and build that in.